is showing. Oh, thanks, Austin. Excuse me for my cough. Another thing to keep in mind is if you have not had a chance to download the training material, I would recommend that you do so now. So the training material link is already there. And I believe that Austin has already put that. So Austin, if you want, you can also put the training material one more time. The reason is if you go down, what I have done is I have linked the slide deck here, which Austin has already put. But in addition to that, I'm also linking this Word doc that I prepared, which is essentially just a list of commands you will be using. So if you want to do this more in an interactive style, just copy pasting those commands will be helpful. It's a Word document, so do keep in mind sometimes it could introduce some funny characters. I was trying to upload the text file, but it was not letting me do that. So just be mindful of it, but I'm hoping that this should help you with a quick copy paste onto the terminal instead of you typing everything, because sometimes that'll slow you down. And if you want to follow along the exercises, doing a copy paste is much easier. Okay. So just wanted to highlight that if you want, take a few seconds to download the training material in terms of the Word document and the slides, which is the PDF. And don't try to copy paste anything from the PDF because that's not going to work. Okay. Any questions on accessing the training material so far? So everyone is on board on how to get the material, right? Okay, great. So moving on. So as all of us probably would already know, that Python is a high-level, general-purpose, object-oriented language that really gives emphasis on code readability. So this is very different from some of those compiled languages or the machine languages, the low-level machine languages that are a lot more in tune with how the compiler is supposed to work versus how the user is thinking about it in their head. So that's why when Python came, it gained this popularity because of its emphasis on code readability, and it's easier to just translate whatever you have in mind onto your code when you're putting it together. And on top of it, it really uses, it gives good amount of emphasis on the indentation. So when you're putting a function together or a class together, you have to be very careful about the indentation of your commands that you're using and where it is placed with respect to your declaration of a function or a class, things like that. But it is because of its ease of coding and all the advantages that come with an object-oriented programming, it is ideal for scripting in any rapid application development because it's just easier to put those things in code. It lets you do a dynamic typing, which is not the case when you're trying to work with these low-level machine languages. So that's why it is so popular even till today. And then it's highly syntactical. It's the emphasis in the Pythonic way is that how everything can essentially be put in a single syntax if possible. So that's the other emphasis that it looks for that elegant syntax. And on top of it, it lets you do garbage collection. So there is an automatic memory management that is happening, which may not be the case with some of these compiled languages like C or Fortran, where you might need to do that on your own or make it a part of your code, the garbage collection. But in Python, that is already happening. Then on the other advantage of using Python is that it has a comprehensive standard library. So you can import a lot of such libraries in your code before you even get started on putting your signs together in the code. And then that will actually make it very easy for you to import these packages and include them in your code. So that's why it's also known as batteries included language, because these essential libraries are already a part of Python package. So you can easily import it and then move on with it. In the back end, the implementation of Python is mostly in C. So the core interpreter of Python is CPython, which is written in C. And there is a little bit difference in terms of the overall speed that the language offers when it's computing, when you compare it to something like C. So Python comes under the category of what is called interpreted languages. And these are slower than compiled languages like C and Fortran, because compiled languages generate an executable on the very get-go itself. So you compile your C program or you compile your Fortran, it will always make an executable, and then you use that executable to run the program. On the other hand, for interpreted languages like Python, you don't need to compile it, but the instructions are executed on the fly. So whatever instructions is part of your code, everything is getting executed on the fly, and then you're moving on. So that is what adds to this latency, to the slowness compared to compiled languages. So there are these pros and cons that one needs to keep in mind when they are trying to think of a problem and work on it. But if it is a Python heavy workflow, there is no way out. You need to use Python. However, now there are a lot of advances that have been put in place to accelerate Python programming itself. So in a lot of places, it is giving you comparable speed to C and Fortran already, okay? But again, it depends on how knowledgeable you are or how much you know about Python to use those type of features. But that is not the highlight of this training session, so we won't invest too much time on that. So keeping all these basics of Python in mind, what we're going to do is directly see how to execute a Python workflow on the cluster. Okay, so I'm going to pull up a terminal here. And once you can see my screen, this is what, hold on. So what I will have to do is, sometimes it becomes an issue. I will pull the terminal here. Okay. Okay, all of you can see my screen, the terminal, and also the browser, correct? All right, so now what I need to know is if you guys can see the font properly. And I am going to bring up my commands that I had prepared.
I think make the font a little bigger.
Bigger, okay. Thank you. Is this any better? No?
Yeah, it's better, but it's still not coming through on the video very well
Okay.
for me.
How
That
about
looks
now?
good.
This looks
Yeah,
good?
perfect.
All right. So let me open my commands file. And so this is what I would do. I will essentially just copy paste these commands into the terminal here. And you can replace the username with your FASRC username. So in my case, it's I'm Joshi. I'm gonna log in. All right. So now that we are logged in, what we will do is, if you go through the presentation, the next is that we have logged into the Canon cluster now. So we are on the login node, but from here, we are actually first going to go to a compute node on what I'm calling it as a test partition. So we'll just learn how to get to a compute node And this compute node is that on the test partition. So again, I'm gonna copy paste the salloc command, which is what is used to obtain a compute node interactively. And I'm requesting the resources to be allotted on the test partition with 1 node and 2 CPUs per task, with a 12 GB memory and 30 minutes of time allotted to my job. And for some reason, it said unable to find command partition. So let me see. Sometimes it could add these funny characters. Right. Not sure. Can someone confirm if they're having similar issue here? Yeah, are they experiencing any slowness on their side? Yeah, that's what I tried, but for some reason, all right. Hopefully this should, okay. Let me try that again. It All right. So while the resources are getting allotted, what we want to do is, so whenever you are on a compute node, the first thing you want to do is what modules are available for, say, Python, because this is a Python focused training. So we're only going to think about Python here. So the best way to do that is to execute module spider command. Module spider followed by the package name. So in this case, it's Python. So we just want to see what all packages or versions of Python are available. So if I type this, it will show me that in total, we have these 5 versions of Python, and you can get specific information for a particular mod for that version. So for example, Python 3.12, which is the latest one that we have added, if we do something like this, right? So if I go back to that, what I'm saying is if you want to get a detailed information on a specific module, this is how you can do that. So if I now hit enter, I'm getting detailed information on Python version 3.12. And what it is saying is that it's been obtained using the Miniforge distribution. And this is the version of Python you're going to get in your path once you load this particular module. Another thing to keep in mind is that sometimes after you load, you can also run echo $path to see what all things have been added to your path. So I'll show you this. So if I do module load Python, what it will do is it will load the latest version, which is also the default version of Python. So this is what is said here, that if we do, I think there's somewhere we probably mentioned this, that if we do just module load Python, then it will always load the latest version. So the latest version is going to be the last version that's shown here. But if you are interested in a specific version of Python, then you will have to say module load Python followed by the version name. So let's say if I'm interested in 3.10.13, so I will have to type that 13 and then FASRC 01. Okay, but right now I'm gonna just do module load Python. And if I do module list, it will show me what modules have been loaded in my environment. So it's the Miniforge version 24.7 and Python 3.12. And now if I do echo $path, I can also see that all these have been added to my path. Okay. So just something to keep in mind when you're working with modules that you're loading. So these are cluster wide. So when you're working with these central modules, good to know what all has been added to your path if in case you need that information. Also, if you want to know more about how to be comfortable with CLI and how to execute your workflow on the CLI, please look up our training material on this particular, on our training website. So this is already linking to the training, the slide deck that we have for FASRC, getting started on FASRC cluster with CLI. Okay, now moving forward. So what we'll also do is, in addition to the training material that you already downloaded from here, we will also go ahead and download some of the examples we'll be covering in this training from our user codes repository. So I am going to go back to my text document here. And so for now, I'm going to keep, so right now, if I do PWD, it'll show me that I'm in my home folder. Now it's up to me whether I want to stick to my home folder or I'm just going to change the location to a different one because I want to keep my home folder as light as possible. So instead of that, what I will do is I will go to my Holy Labs location that I have, and that is here. So I'm choosing to go to a desired location that I want. So again, you can decide the same thing. You can stick to your home folder, which is fine. But if you want to keep it light, you can switch to a different location like Holy Labs. Now, what we will do is we will then get this repository, which is located on our user codes. And if you look at this, the user codes repository is already linked here. So that is essentially our GitHub repository for all the examples and user scripts that we offer to people. So this is the GitHub repository, but we're going to clone that. So I'm going to go back to the presentation, and then I am going to clone using SSH. But if in case your SSH keys are not added on your GitHub account, it could give you error, in which case you should use the HTTPS route to clone the repository. Okay, so try whichever one works for you. So I'm going to stick with the SSH one. And if I go back to this, all I need to do is copy paste the git clone for the SSH part. Okay. All right, so now that this is cloned, I don't want to run anything in the repository that I have cloned. So the user codes is right here. What I will do instead is I am now going to make another directory called Python training right here. Okay. And then I will move to this Python training directory. And once I've done that, what I'm going to do is I'm going to copy this particular portion, CP-R languages. So from the languages folder under user codes, there is a folder called Python. So you're going to bring that over to your Python training folder. Reason is, if you try to make changes to GitHub repository, then if you're not following it, if you're not updating it, sometimes it can cause issues. So it's easier when you are trying to run the examples to make a copy of it in a separate directory. The one that you see after that, which is asking you to copy this particular folder, Python multiprocessing tutorial, that is actually slated for tomorrow. So you don't need to worry about this for today's training session, which is basically based or focused on running your basic Python workflow on the cluster. Okay, so what we will do here is, now before we start running the Python examples, remember we loaded the Python module. So we are also going to check what Python version are we running. And because we loaded Python module 3.12.5, that is the Python version we are running, which is fine. Any questions so far before we move on?
We have a couple questions about SSH and HTTPS commands not working for Sarah. Sarah, are you referring to for cloning the Git account?
Yeah. Can you just go to, in that case, let's just put the folder. So I'm gonna just put that link. I think Austin, you already put that. Sarah, can you go to that, and then what you can try is, you see this codes tab. If you open it, click on the HTTPS and then do copy URL to clipboard. So copy that. And then on your terminal, just do git clone and then followed by that. Can you do this?
That does presuppose that you have Git installed on your system. If you don't, you can also just download the raw source code through the web interface.
Yeah. Okay. All right. So let's move on then. So what we will do here is we will now just really execute a basic Python program on the cluster. So as I said, because we want to execute a program, we need to be on the compute node, which we already are. So from here, we will now essentially see two ways. One is by directly invoking the Python interpreter on your compute node terminal and then typing up the program there. So I'm going to do that. So I do Python, and then I would actually just copy paste this entire thing. Oh, and then it is not like that because of the indentation. So now, so I won't write the command, but I'm just gonna do this, and then so this is done. And then I will do next, which is this. That's it, right? So this is how it's a basic program to do a square of numbers from 1 to 4 and 1 to 3. And this is essentially the output that you get. So you executed a basic Python program on a compute node using the CLI, okay? And then you can exit using this. The other thing you can do is you can directly run this script. So if you go into the Python folder now, there is a script called myscript.py. If you were to do just Python followed by myscript.py, it will essentially do the same thing that you just did it on the terminal, okay? So this was running a Python job interactively, right? So you went to a compute node, used the terminal prompt of that compute node, and did your programming. What we are going to do next is how to do Python programming using the non-interactive method, which is sbatch. So this is the first example there. And what we will do is, in this first example, so under the Python folder, you will see this thing called example1. And in that example1, we have a couple of things. So one is your run.sbatch file. So this is your batch job submission script, which basically looks like that. It tells the scheduler what all resources you are asking for. So any batch job submission script will have essentially 3 sections. The very top section, this called the shebang, is what is telling the scheduler that you want a bash shell environment. And then what you see here under sbatch are the header. So this header, or called the sbatch directives, are used by the scheduler to figure out what all is needed to schedule the job. So in this case, you're saying, I need one node, I need 1 CPU per task. I want the partition to be serial requeue, and I want 30 minutes time, and I want 4 GB memory. So all these directives are being given to the scheduler to allot those many resources to your job. And then the third section is where you're actually doing your science. So for in this example, you're saying, I'm going to load the module. I'm going to then run my Python script. And the Python script here is, so that is a source code that calculates your pi, the value of pi, using Monte Carlo methods. So that's the example we are using. So if you want to see the Python script, it's a pretty simple one. So all it does is it essentially takes your pi value, and it is constantly comparing that pi value from starting from I0 to this 100,000 range, and then using the Monte Carlo method to give you the estimated value. So you have the exact value that you have already provided, which is this. And then you will also do your estimation using the Monte Carlo method that is described here to see exactly how far you are from your exact value. Okay. Now, what I will do here is I can submit my job from here, or I can submit the job from the login node. So this is one advantage of submitting a job using sbatch option, that you don't need to be on the login node. So what I will do is I will exit from the compute node because I don't need it anymore. Also, I just want to make sure that there are no modules loaded, because a lot of times what happens is if there are modules loaded on your login node, if you submit a job, all that environment gets carried over through your job submission. So you want to enter a compute node with a clean environment, and all your module loads should really happen through the batch script. So what I mean by that is, if I go back to, because it brought me to my home folder, if I go back to that example I was talking about, which is example 1, and if I open my batch script now, in this case, I am loading the module Python because I know I need that to run my Python script. So I'm going to enter a compute node with a clean environment, and then all the environment that I need to run my job is going to happen here through the batch script. So that is the recommended way when you're trying to execute your workflow on the cluster. And then all I need to do is sbatch run.sbatch. So I submit that program, and what it will show you is it will produce 2 files. One is the output file. So this is where you will see the final output, and then the error file. So technically the error file should be empty if there are no errors reported while running the job. So now I'm going to do an ls to see if my job ran, which it did in this case. So I can do sq-me, and it shows clear. That means my job is done running. And it has produced 2 files, the mcpy.err and mcpy.out file. So now if I do mcpy.err, if I open that, it's empty as expected. And then if I open the out file, I can also do more instead of Emacs if you are not familiar with that. So it'll just list out the contents of the output file. So it is now saying the exact value of pi is what we had provided in our Python script. And then the estimate of pi that we obtained using that Monte Carlo method by ranging from 0 all the way to 100,000. So this was the final estimate that the program produced. So it's fairly close to the exact value that we provided. Any questions about submitting a job or moving to a login node from a compute node, things like that? Okay, if not, then we will move to our next example.
I did to include the convenient Slurm commands in chat if anyone is interested.
Yeah, exactly. I saw that. Thanks, Austin. So that is another good article to keep in mind whenever you're running Slurm commands on the cluster. So the one link that Austin has shared, please take a look and bookmark it, because that will come in really handy. So now what we're going to do is, before we do the second example, we will learn how to actually create or a conda or a mamba environment and then install a package. Okay. Now, whenever you are trying to install a package, please always move to a compute node. Don't try to do this from a login node. The reason is login node is all the resources on the cluster are shared, but login nodes specifically are less in number and they're used by multiple, like hundreds of users on a daily basis to enter the cluster. So if you slow down the login node because of your computationally intensive workflow or because you're trying to install packages, it impacts all other users who are trying to enter the cluster. So your usage of the login node should be very minimal. You get into the cluster using the login node, and from there, jump to a compute node for things like package installation, running a script, doing a computationally intensive work. Okay. So keeping that in mind, now I'm going to go back to my text file here, and then I will copy paste. I want to move back to the compute node. And so I'm choosing to be in the same directory. And then I will do this. So now that I'm on the test partition on this particular compute node, what I will do is I will now start creating a Mamba environment. Now, there are two things you can do when you want to create a Mamba environment. One is you can choose to create the Mamba environment on a certain location, because the default location of a Mamba or a Conda environment is your home folder. So if you don't specify the location, it is going to put it on your home folder. Now, that is fine as long as your home folder doesn't fill up. So right now, the home folder that we have comes with a quota of 100 gigs. And when you start building these Conda or Mamba environments and start installing packages, it actually fills up these things pretty fast, unless and until you're cleaning your Conda environment pretty regularly. So that is one thing to keep in mind. And again, I have linked our documentation that is related to Python package installation here. So please take a look and read through it. We also share some good practices that you can adopt so that you're not filling out your home quota because of building these Conda or Mamba environments. Okay. So what I will do is, for now, I will just choose to put my environment on a desired location, not on the home folder. But if you want to stick to the home folder, you need to follow the second one. So for now, I'm gonna do a module load Python. And then I just like to do module list to make sure that everything is in my environment before I get started. And now I am saying I will. So what I'm saying is that I want to redirect this to my labs folder. And then in the labs folder, because I'm part of the RC admin, I will put it under that. And under that, there is a labs folder. Oops. And then there is an mjoshi folder. So I am going to redirect this Conda or Mamba environment on this location using the prefix flag. Okay, so prefix is what is used to redirect your environment and package installation to a location of your choosing. Also keep in mind that whatever folder you end with, so in this case, I'm ending with multiproc_env, that is where all your packages will get installed. And on top of it, the name of your environment, in a way, will be this entire location. All right. So that is one thing to keep in mind whenever you're using the prefix flag, that the entire path becomes the name of your environment. So when you're trying to activate the environment, you will have to choose you'll have to use the entire path. So that is one thing. It's very important to keep that in mind. There are some tricks to get around that. Bear in mind that this is how you should do it. And now what I'm saying is that I want this environment to be created with Python version 3.11, not 3.12. But again, this is what I'm choosing. If I remove this, then it will just create it with the default that is coming, which is 3.12, because that's the module I've loaded. But right now, I'm saying I want Python. That's just what I decided, but you can choose to just stick with 312. So you can remove that. And dash Y is because it asks for that, okay, is it okay to install these packages? So you don't want it to be stuck on that prompt. So that's why you provide dash Y. So now that I have issued this command, it's gonna take some time. So we will move on. And what we will do next is that we will just go through the packages that will be installed after activating the Mamba environment. So this is what this particular slide is talking about, that you activate using the entire location of that where you have put that folder that has all the packages. But if you're using the home folder, then all you need to do is Mamba activate followed by the name, because the location is home folder, which is already default for Mamba. Another thing is that you could apply tricks like actually declare your conda package location in your .conda rc or in your .bash rc, in which case then you don't need to remember this entire path. But the advantage of remembering the entire path is a lot of times it's easy to forget what's in your .bash rc or what's in your .conda rc. And then sometimes that can result in conflicts. At least that's what we have seen with our users. So either you be mindful of where you're putting your environment, or if you're using home, then it's an easy way to activate. So what will happen is once the environment is done getting created, we will then install these packages. And here I've intentionally included two examples. So one is a simple Mamba install, and then we'll do NumPy, Pandas, Matplotlib, whatever packages that you need. And then we will also be doing a pip install of these two packages, Swifter and Jupyter Lab. So this is again to highlight that how you should make sure that you're doing a pip install inside a conda Mamba environment to avoid any package conflicts. And this particular page, the document links to that. So again, we have seen that a lot of conflicts happen down the line if you end up doing pip install outside of conda environment. Reason being that when you do a pip install outside of conda environment, all your packages get installed in your .local folder on your home folder. And then if you're installing similar packages or same packages in a conda environment, then there is going to be a cross connection, and that will result in errors. So we always recommend all our users to do a pip install inside a Mamba or a conda environment. So now this is almost done getting created. So once those are done, I'll just copy paste that. So from here, let me move on to the next one. So what you are seeing here is actually a part of example 2. So whatever we did interactively about creating a conda environment or a Mamba environment and then installing Python packages, all that can be done using an sbatch script. So this example shows you how to just submit an sbatch script that will load the Python module for you. It will build the environment. So this is a bash script that it calls and it runs that. So this particular script builds the environment for you. Then in this particular stage, that environment is activated. And once that is activated, then you start installing your, oh, I'm not showing that here. You can install your packages and then you can run the Python program that you need to run. So this is just an example of showing how a package installation can happen in an sbatch format. So where you don't need to do this interactively, you can just submit a batch job and all this will get created in the background. All right, so now going back to the interactive portion of this, now that the environment has been created, all I need to do is copy this whole thing and then activate that environment. So now you see this, the entire path to my environment has been attached to my prompt. So that is what, and that is how I know that I'm in this particular environment. So this is very important. You need to have this so that you're sure that you're inside a conda environment. And now that once I am in my environment, all I'm going to do is I am going to start installing these packages. So first I will do my Mamba install, straightforward. Again, I have to put the minus the dash y so that it doesn't stop for the prompt and it starts installing those. And while it is installing, what I would like to show you is the other example I was talking about, which is that of the sbatch. So for the sbatch, because the program is running there, I'm going to go to our user codes because everything was taken from there. So inside that, there is the languages folder, there's the Python folder, and there's example 2. In example 2, you have the build environment that is essentially doing what we did interactively, but here everything is going to be installed in your home folder because we are not providing a prefix. So we are not providing a location. So it will go to the default location, which is your home folder. The name, the dash n stands for the name of the environment, which is my env. And then we are saying build this environment with Python, the whatever the default version we have, which is based off of the whatever Mamba is at. So that Python will be installed. Then on top of it, we are installing few packages in this while the environment is getting created. So that is pip and wheel, pandas, and numpy. Okay. So you can do that too. If you already know what packages you need to be installed, it's in fact better to do this while creating the environment, because otherwise it can have an overhead, it can slow things down. On the other hand, if you install these packages while creating it, it's actually faster. All right, so this is again, if you already know what packages you need installed. So this particular script, it's a bash script. It will take care of creating the environment and also installing these packages for you. So now what will happen is, once I have this in the bash script, what I have done is I have made this part of my sbatch, the job submission script. So again, as I said, the job submission script has 3 sections. One is whatever bash shell you want, whatever shell environment you want, the directives you want the scheduler to be aware of, and then where you're doing your signs. So here we load the Python module, we build our environment, we activate our environment, and because it's on home folder, I don't need to provide the location. It's just mamba activate my env. Now my environment already has those packages installed, so I don't need to do any more installation here. And then I will just run this Python script. Okay. And if you look at the Python script, it is basically producing these data frames and printing them out. Okay, so that is what it does. So when you run this job, the final thing, once it's done running, it will produce an output file called nppandas.out. Because if you look at our batch script, we are directing it. We are saying the job name should be nppandas, and this is the output and the error file that should get created, the .out and .error. So if you look at the .out file, so it will actually tell you the whole story of what all you did through your batch script. So we asked it to run our bash script to create the environment and install these packages. That is what it did. And once it was done doing that, then it activated the environment. And after it activated the environment, it ran our Python script and produced these data frames that we asked it to produce. Okay. So in the interest of time, because interactively, this is still building up. So what I will do is I will have to come back to it because I wanted to submit that program. So let's circle back on that and I'll show you. It's an easy, simple thing. You go to your example2 folder and you just say sbatch, run.sbatch, and all these things will be executed. So we will circle back on it because we need to move on to our third phase, which is executing your Python workflow using the web interface that we have, which is called Open OnDemand. Okay, so the advantage of using Open OnDemand is all you need is a browser. It's agnostic to whatever operating system you have. So it doesn't matter whether you're coming from Windows or Mac or Linux, all you need is a browser. So it works really well as long as you have Chrome or Firefox. We have seen issues with Safari, so that is not recommended. So at least in terms of the browser specification, as long as you're on Chrome or Firefox, you can easily run OOD. Okay. So in order to, and if you still need to be familiar with OOD, this gives you the link to our presentation slide deck. And again, if you look at our training calendar, it'll tell you when the next OOD training or the CLI training is going to happen. But all these are links to the previous presentations that we have done on OOD or on CLI. All right, so now I'm gonna just check. Okay, it's almost getting ready to be done. If you are a Canon user, you would need this particular URL to get connected. If you're on FASRC, then these are the instructions to get started on FASRC, where you need to be on the FASRC VPN. So this is what it links you to, and then go to FASRC OOD, all right? Another thing to keep in mind if you're a FASRC user is sometimes you might need to set some proxy settings in order for some of the apps to work. So this is a document that shows what all proxies you would need to set. So for example, if you want to use Jupyter Notebook, you will have to run these commands on FASRC prior to starting your Jupyter Notebook. Okay, so just something to keep in mind and go from there. But what I'm going to do for now is I will essentially show you how to access Jupyter Notebook when you are on Canon OOD. So put my credentials. So here, this is not two-factor authentication. You just need your username and password, okay? And then when you sign in, so this is how your landing page would look like. So you will have these clusters and you can start another terminal session using that. This is how it'll open an interface, which will basically list all your files in your home directory and things like that. This will show you what all active jobs you have, or you can even compose a job using this feature list of interactive apps, which we already have here. So it's the same list. And then this will tell you your interactive sessions that are currently active. For example, we will start this right now. I want to launch a Jupyter session, right? So I'm going to click on this. And then this is the form you will have to fill out. You will have to specify the partition. You will have to specify what memory you want, number of cores. So I'm going to I want just 2 cores for now. I don't want any GPU, the allocated time, and working directory. If I'm not specifying, everything by default will open in your home folder. And then if there are any extra modules that I need, for now, I don't need anything. So I'm going to then click on launch. Okay. And then what will happen is in few seconds, I will see a launch button appear here. However, if I click on my session ID, I will see it'll open another page, and then you will see some of the scripts, including output.log. Sometimes this is interesting to know. If by chance your app did not open, output.log will record the error. So it's just good to know that where it is located. So now if you click on connect to Jupyter, it is going to open. So typically it opens the last time it remembers it's in its cache, the last location you had access. So that is where it's brought me to. But if you click on this folder sign, it is basically a list of all the folders and file I have on my home folder. So that is a way to open a Jupyter notebook, and then you can execute your Jupyter notebook from there. So that is, where are we? So we are here. I talked about the FASRC proxy. This is essentially, again, talking about the form that you need to launch. And again, you will have to be mindful, depending on the cluster you're using, Canon or FASRC, the list of partitions change. Okay, the name are slightly different, and the resources each partition offers is also different. So please take a look at this before making a decision in terms of what partition you need to use in that form, because you will have to fill out that form with the partition name. And for example, if you click on FASRC, this lists all the FASRC partitions with all the resources that are available there. Okay, so these are just some of the things to be mindful of before filling out the form. And by the way, now if I click on my interactive session, it'll show the interactive session that is currently going on. So it's always going to list the active sessions that are there and some of the deleted sessions that will keep on for a few days. So if you want to come on the my interactive session. All right, so now this is, again, I told you how to launch Jupyter Notebook, but what I also need to tell you is if there is a conda environment you've built, how you can load it to your Jupyter Notebook. So for that, we will go back to the interactive one that we had built. So remember, the last we did was we installed NumPy, Pandas, Matplotlib. Now, what we will do is we will also do a pip install, and we'll install two packages. So it will install Jupyter Lab and Swifter. Once we install Jupyter Lab, we will actually be able to open this particular environment in our Jupyter, in the Jupyter Notebook here. So what I would need to do here is I will have to reopen this session because the package was not installed prior to opening the session. So as of now, if I click on my Jupyter Notebook and if I go on kernel, and no, so I think, sorry. So if I click on a Jupyter Notebooks, let's say I click here, and if I click on kernel, I won't see, so this is what you see here, multiproc underscore env is from before. I won't see the one that I currently built, but this is still a good example. So if you have built an environment, once you open your Jupyter Notebook, you can access that environment by clicking on the kernel and making it switch to the kernel you're interested in. So this is the way to load a conda environment or a mamba environment into Jupyter Notebook on our cluster using the kernel approach. Okay, so once you click on this and you say select, then it will now activate that environment for you, and you will be able to run your Jupyter Notebook that needs that environment. Is that clear? Any questions? I just want to make sure that people were able to follow this, because sometimes it's easy to get confused in terms of how to load an environment into your Jupyter Notebook. Okay. All right. If not, then what we will do is move on, and I am going to. So now our environment is completely built. We have, if I do conda list here, it will list all the packages that I have built, including Swifter, and then we put Jupyter Lab. Okay. The Jupyter Lab is here, and we also did NumPy and things like that. Okay. All right. So now we are almost at the end. So the main way to activate your conda environment in a Jupyter Notebook is using the kernel. And another thing to keep in mind is to make sure when you are closing your OOD windows, if you do that for Jupyter Notebook, that session will not survive. So if you want that session to survive, you will have to choose a different route. And the documentation for doing that is here. You will have to open a remote desktop app on OOD, launch Jupyter Notebook there, and then run it. Okay, so this is another thing to keep in mind if you want your Jupyter Notebook session to stay alive in the background, to stay active. So this is just a list of some of the documentation we covered in this session, including the Python docs that I referred to. So please take a look. This is a link to our GitHub user repository and how you can get help by coming to our office hours or initiating a ticket. Best is to just email us. It will automatically open a ticket. But this is again how you can get help if you are having any issues with your workflow on the cluster. And this is our upcoming training. So we have a training tomorrow on how to execute multiprocessing in Python on FASRC clusters. So if you're interested in that, again, the premise will be utilizing multiprocessing and accelerating your Python on the cluster using the right resource allocation. Okay, so that is another thing to keep in mind. And please feel free to send your feedback to us. That will help us improve our presentation even more. Okay, and with that, thank you.